Bellabot. Bellabot, the cutest robot there is to efficiently serve food. Dishes, napkins, documents, and other items. It offers users an unprecedented experience with food delivery robots. The latest delivery robot designed by Pudu, Bellabot inherits the outstanding characteristics of the previous generation, while being endowed with superior human-robot interaction capabilities. Featuring an innovative bionic design language, cute modeling, AI voice functionality, multimodal interaction, and many other new functions. Robot Cook. This is food robot. It can fry chicken wings, French fries, and other foods, season them, and plate them all autonomously. Robot Chef solves the problem of understaffing for most restaurants, fast food, and high-volume kitchens by complementing or taking over the job of human beings, thereby reducing cost and enhancing customer experience. Cheetah Robot. Cheetah Robot has four-legged that can run and do backflips. It is robust and has powerful controller, allowing researchers to perform experiments and test new controllers without fear of breaking the robot. This is a new version of a very quick quadrupedal robot from MIT's Computer Science and Artificial Intelligence Laboratory. Cheetah Robot is a quicker learner. That's because a team of researchers recently used a machine learning enabling it to set a new speed record of 18.0 miles per hour. MX Phoenix Hexapod. MX Phoenix is a six-legged hexapod walking machine with 3 motors on each leg. Halvorsen told Digital Trends about his latest creation. Almost all parts are 3D printed in ABS plastic. It's remotely operated using a custom-made remote controller. Unlike most of the hexapod robots, MX Phoenix is able to walk on rough terrain, not just flat and level floor. All 18 motors are controlled using advanced control algorithms that are computed inside an onboard microcontroller. Bionic Kangaroo. This Bionic Kangaroo is a robot model developed and made by Festo in the form of a kangaroo. Festo's researchers and engineers studied the way kangaroos move, and applied that to the design of a robot that moves in a similar way. The robot saves energy from each jump and applies it to its next jump, much as a real kangaroo does. Bionic Kangaroo is able to realistically emulate the jumping behavior of real kangaroos, which means that it can efficiently recover energy from one jump to help it make another jump. Without this capability, kangaroos, real ones, would get very tired very quickly. But by using their tendons like elastic springs, the animals can bound at high speeds efficiently for substantial periods of time. Bionic Kangaroo emulates this with an actual elastic spring, which partially charges the legs on landing. Kawasaki Bex. Kawasaki has unveiled a rideable goat-shaped robot that has wheels and can carry a human being on its back. Named Bex, the four-legged robot is modeled after an ibex, a type of wild mountain found in Eurasia, North Africa, and East Africa. The robot can be outfitted with a passenger-carrying back that supports a rider up to 220 pounds, 100 kilograms. The ride can control the robotic goat via the handlebars. Kawasaki Robotics says Bex could be used to carry crops on farmland or to transport materials at a construction site. Spot Mini Robot. Spot Robot, earlier called Spot Mini, is a four-legged robot developed by American robotics company Boston Dynamics. Spot Mini is the smallest dog robot yet. Spot is a compact, agile four-legged robot that can scurry around your office, home, or outdoors. It can map its location, recognize and avoid obstacles, climb and descend stairs, and open doors. It can also fetch your favorite drink and a glass without breaking the glass. Spot weighs only 25 kilograms and is 83 centimeters tall. Spot can perform a number of functions including climbing stairs and navigating rough terrain with ease. It is small enough to be used indoors. Snake Robot. The key component of this intelligent snake robot is a sensor-based control. Sensors embedded into the Snakebot's body would enable it to make autonomous decisions about its movements. Part of that development will include writing software that will allow the Snakebot to learn from its own experience. The main body of a Snakebot consists of about 30 identical, hinge-like modules that are linked together in a chain. These modules are connected by a central spine and work together to perform various functions. The snake robot frame will be constructed out of a polycarbonate material and covered by an artificial skin to protect it from the Martian elements. Squidbot. Squidbot, developed by engineers at the University of California, San Diego, that uses a combination of soft and rigid materials to propel itself through the water much like the real thing. This action produces jet pulses that propel the robot through the water, much like a natural squid. In effect, this means the Squidbot is able to carry its power source within its body, eliminating the need for a tether. The scientists behind the machine believe it is the first of its kind. The fastest aquatic invertebrate is the squid, clocking in at some 10 to 25 body lengths a second, or 36 feet in that same time. Without a bone in their bodies, the mollusks have a completely different mode of locomotion than the vertebrates of land or sea. And yet, unlike seemingly every other creature, the roboticists have yet to turn to the squid for inspiration. Bionic bird. Bionic bird is a realistic smartphone-controlled bird that can flap its wings and fly indoors or outdoors at speeds up to 12 miles per hour. Just charge it for 12 minutes on its unique egg battery, which holds 10 charges, download the app, and connect it via Bluetooth on your iOS or Android device, and toss it into the air to begin its flight. Each charge lasts up to 8 minutes and it has a range of around 100 yards away or until it inevitably lands on a roof or in a tree. Bionic bird is like a real swallow, especially in its ways of flying. We own Edwin van Ruymbeek, this furtive and ultra-manageable robot bird, who is a French engineer. During an AFP interview, he said that the idea has been incubated for a long time, except that at that time, the technology still didn't allow the faithful reproduction of the bird's wings.